geometry students, let's go ahead and get started with our third day of review. Now, we left off in the last video looking at what a geometric mean is. So let's quickly go over that again, and then we'll continue on. Now, the geometric mean, if I told you to find the geometric mean of 2 and 10, there's two ways to do it, and you really need to know both ways. And there's a reason why, because sometimes I will give you the geometric mean, and you'll be missing one of these numbers. Okay? There's two different ways to do this. First of all, the geometric mean of two numbers is the square root of those two numbers being multiplied. So if I told you to find the geometric mean of 2 and 10, you multiply those two numbers and take the square root of them. Okay? Now, another way to do it is to take your two numbers, put one of them in the top of a fraction, put the other one in the bottom of a fraction, and then set the two equal. Then put an x here into x here, and then solve. X times x is x squared. 2 times 10 is 20. And then take the square root of both sides, and you get the square root of 20. Okay? So I just wanted to review that real quick. We looked at that yesterday. Now, moving on. Let's look at Theorem 9.2, okay? Theorem 9.2 states the following. In a right triangle, the length of the altitude drawn from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse. So let me give you a picture of what this means, okay? Here's your right triangle right here. I would copy this in your notes if I were you. I would copy this too if you want. I mean, it's up to you, but do you notice, students, let me pause and say something. I'm not giving you a bunch of problems and saying learn these problems. I'm giving you principles of things you need to know, and then you're going to have to know these principles and be able to apply them to different problems. And so make sure you understand that, okay? So, this is a principle I want you to know. The length of the altitude drawn from the right angle. So here's the right angle, and I'm going to draw this altitude right here, okay? Now when I do that, here's what it says. The length of the altitude, I'm going to call that x. So put an x here. Is the geometric mean of what two numbers? Remember, if I say find the geometric mean, I have to have two numbers that I'm using to find the geometric mean. So this slide right here, this length right here, this altitude is the geometric mean of what two numbers? Well, it's the geometric mean of the lengths of the two segments of the hypotenuse. So we're going to call this segment here in green Y. We're going to call this segment here in blue Z. Okay? So this length right here in black is the geometric mean of these two numbers here. Let me say that again. This length right here is the geometric mean of these two numbers here. So it's really quite simple. See these two numbers up here? If I told you Y had a length of 2 and Z had a length of 10, then you would simply find the geometric mean of those two numbers, and that would be the length of this altitude right here. So when you're given a right triangle, and my original triangle was a right triangle, when you're given a right triangle, if you draw the altitude from the right angle to the hypotenuse, this length will always be the geometric mean of these two numbers right here. Memorize it, know it, get it. Now, here's where it gets tricky. Sometimes I'll give you this length here, which is 4, and I'll tell you to find one of these lengths right here. Okay? Now we're going to practice that in just a second. But that's where it gets a little tricky, okay? Alright, so I would like you, please, in your notes to go ahead and copy this down. I'll wait a second for you to do that, okay? Copy this triangle down, and then copy down this problem here that I want you to solve. I'll give you just a minute to do that. Now please take some really good notes, students, please. Now here's my right triangle. See it? There's my right triangle. Then notice I've drawn an altitude from the right angle to the hypotenuse. Okay? So here's what we just learned. If I have a right triangle and I have the altitude drawn from the right angle to the hypotenuse, this length here, RT, is the geometric mean of this length here, QT, and this length here, TS. So you know what I would recommend that you do when you see that? Set up a formula. Set up a formula. Come back up here, students. If I told you to find the geometric mean of 2 and 10, you put a 2 here, a 10 down here, and you put your geometric mean here and here. So instead of putting x's, I'm going to go ahead and put geometric mean, okay? So use that down here. Is QT the geometric mean? No. Is TS the geometric mean? No. RT is the geometric mean of these two segments. So if RT is your geometric mean, then put RT right here and put RT up here. See how easy that is? And then your other two spaces here would be segment QT and segment TS. There it is, guys. So if you'll establish which segment is the geometric mean and write that twice, diagonal across from each other, then the other two segments fall right in place. Now using this formula right here, let's solve problem number 1 right here. If QT is 5 and RT is 10, solve for TS. Okay, no problem. Do you not see how easy these problems are once you get this formula written up, okay? Alright, let's come over here. So QT equals 5. Well, here's QT. So I'm going to put a 5 right there, okay? Fraction equals fraction. Here's QT, I put a 5. RT is 10. Well, here's RT and RT. So I'll put a 10 here for RT and a 10 here. Find TS. Well, here's TS, so I'm going to put an X. Look how easy this is. 5 times X is 5X. 10 times 10 is 100. Divide both sides by 5, and X equals 20. Students, this is the key right here. When you get this formula right here written correctly, everything else falls into place. And how did I write this formula? Ask yourself which segment is the geometric mean and write that segment twice diagonally. Everything else should fall into place. Okay, let's solve this problem right here. So QT is 4. Here's QT, so I'll put a 4. TS is 9. Well, TS is right here, so I'll put a 9. Now we're solving for RT. Well, since this is RT and this is RT, I can put X for both of them. They're the same. They're the same segment. So put an X here and put an X here. And now solve for RT. X times X is X squared. 9 times 4 is 36. Take the square root of both sides. X equals 6. Look at that. When you get this formula written, it's a lot easier. Okay? Alright, let's move on to another thought. Copy, I would write this down if I were you guys. Need to know this. And I'll give you a minute to do that right now. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Each leg of the right triangle is the geometric mean of the Each leg of the right triangle is the geometric mean of the hypotenuse, and this segment of the hypotenuse that's adjacent. I'm trying not to laugh to the leg. This is like a foreign language, okay? Copy it down. I will explain it to you, okay? Relax. I will explain this to you. I'll give you a couple more seconds. Please copy this down. Okay, I would encourage you to draw 2 triangles in your notes. 2 beautiful right triangles like I have attempted to do. Mine look like they have been stepped on. Now, both of these theorems start off the right way. If an altitude is drawn from the right angle to the hypotenuse, if an altitude is drawn from the right angle to the hypotenuse, so both of these theorems, 9-2 and 9-3, start off this way. So I'm going to draw an altitude from the right angle. I'm going to draw an altitude from the right angle there. Now, here's the difference. Listen to me carefully. This is theorem 9-2 right here, and theorem 9-3 geometric mean of this segment and this segment. Got it? That's what we just learned. Now in this theorem they're telling you this. Each leg of the big right triangle, so this segment here, watch carefully, this segment here is the geometric mean of, are you ready? The entire hypotenuse. And this little segment here that's touching this leg right here. Let's go over it again. I'm going to go over it many times. This leg here is the geometric mean of the entire hypotenuse. And this little segment here that is touching this leg right here. So this red segment is the geometric mean of this whole length and this here. Now also students, we can apply that to the other leg. So see this leg right here, this big leg here. This big leg here is the geometric mean of what? Do you know? The entire hypotenuse again, like we just learned. And this segment right here, from here to here. So this leg here is the geometric mean of the whole leg and this segment here. This leg right here, again, is the geometric mean of the whole hypotenuse. And this little segment right here. So do you see the difference? Over here, theorem 9.2, the altitude here is the geometric mean of these two segments. Here, this leg is the geometric mean of the whole hypotenuse in the segment here. Or you can say this leg right here is the geometric mean of the whole hypotenuse and this segment right here. Okay, so with that in mind, let's work on a problem. I will give you a second while you copy this down, okay? Please copy this down. Please copy this triangle down, and please copy these two problems down. Now, students, look, there are many different, not many, there are different formulas you could write down. Now, if you thought for a second that you were dealing with this altitude here, and this segment, then write the formula like I just taught you. RT is your geometric mean, so you put your GM here, well, it'd be RT, sorry. You put RT here, and then your other two segments, QT and TS, down here. If you thought you were dealing with this length here, we're not though. Look at the problem carefully. Look at the problem and you'll see we're dealing with a leg here and a leg here. Watch. We're dealing with QR, this segment, QS, this segment, and QT. So we need a theorem that says this. There's a theorem that says this leg here is the geometric mean of this entire length here and this little segment here. So which segment is your geometric mean? This whole hypotenuse here? No. This segment here? No. Your geometric mean is QR. So the formula you would want to write is QR here equals, and then QR up here. Always write your geometric mean twice and put the other two segments here. Now, the other two segments are what? QR is the geometric mean of this whole segment, that's QS. And then the segment that's touching this leg, which is QT. And now we're good. Let's solve this problem here. QR is 12, so I'm going to put a 12 here. And a 12 up here for QR and QR. QS is 20. Here's QS, so I'll put a 20. And we're solving for QT, which is here. So X. So 12 times 12 is 144. 20 times X is 20X. divide both sides by 20, and I don't have a calculator. Yeah, here's one right here. Alright, 144 divided by 12 or divided by 20 is 7.2. So 7.2 is x, which is QT. Okay? Now, let's look at the next problem. We're dealing with QT, QS, and QR. So we're dealing with the same segments again, guys. Same segments. Look, we're dealing with QT, QS, and QR. So if we're dealing with the same segments, it's the exact same formula. Which one of these three segments is your geometric mean? QR. So we write QR twice, diagonal from each other. Always write the geometric mean twice, diagonal across from each other. Then the other two segments would be QS, the whole hypotenuse, and QT, the segment touching the leg. So here we go. QT is 4, so I'll put a 4 right here for QT. QS is 12, so I'll put a 12 right here for QS. Find the length of QR. Well, QR is here and here, so I'm going to put an X into X. X times X is X squared. 12 times 4 is 48. Take the square root of both sides, and X equals the square root of 48. Or you could type that into your calculator and get out a decimal, which would be 6.92, or just 6.9. Okay, so make sure you're familiar with those two theorems, students. Alright? Okay, let's continue on to lesson 9.2. Lesson 9.2 review. If you want to look in your notes, you'll find those notes on February 6th, okay? February 6th. This was the lesson in which we studied the Pythagorean Theorem. So as you can imagine, I don't have a lot to say on this lesson, but I still want to go over a couple things. First of all, excuse me for yawning, students, I'm sorry. First of all, you do not need to take notes on these two problems. I'm going to go through them very quickly. I think most of you know how to take L squared plus L squared equals H squared, and to use that to solve for missing sides in a right triangle. A couple things I'd like to point out to you, though, would be, remember, Pythagorean's theorem only works when you're using right triangles, okay? And another reason I want to do these two problems is I want to quickly review how to take your perfect squares. I'm not sure why there's a 2 here. That 2 shouldn't be there. How to take your perfect squares and simplify square roots, okay? So here we go. Let's go ahead and solve for the hypotenuse. Again, you don't need to take notes unless you want to. I have a leg of 1, a leg of 2, and a hypotenuse of x. 1 times 1 is 1, 2 times 2 is 4, 1 plus 4 is 5, equals x squared. Take the square root of both sides, and our answer is the square root of 5. Now, I cannot simplify that because none of these numbers over here will go into 5 evenly. If you want a decimal answer, you would simply type that into your calculator and get 2.23. Now, onto this Pythagorean theorem over here. We're missing a leg, so I'm going to put 4 for one leg, x for another leg, 8 for a hypotenuse. Okay? 4 times 4 is 16, plus x squared equals 64. 8 times 8 is 64. Subtract 16 from both sides. And we would get 48. Alright? Now take the square root of both sides, and there's our answer. Now, if I asked you to write your answer in decimal form, well, that would be no problem. You type into your calculator, and you're going to get 6.928. Alright? However, if I asked you to simplify that, then you would take your list of perfect squares and you would start with the biggest number and see which number goes into 48. Well, the biggest number that goes into 48 is 16. So I would take my 48, I would write 16 times 3, which is 48. Now, which one of those two numbers do I know the square root of? 16. So cross off 16, put 4 on the outside. So my answer would be 4, square root of 3. I just want to quickly review this and move on. lesson we talked about Pythagorean triples, okay? On the test, make sure you know how to check and answer, yes, those three numbers are Pythagorean triple, or no, they're not. You take the two smallest sides and you see if you call them your legs. You take your biggest side and call that your hypotenuse. And so you go 3 squared plus 4 squared equals 5 squared, okay? And what you do is you see if you get out a true statement. Well, 9 plus 16 is 25. 5 squared is 25. Did I get out a true statement? 25 equals 25. Yes, I did. So are these three numbers a Pythagorean triple? Yes, they are. So make sure you understand that process there, okay? Now, moving on to lesson number 9.3. And if you want to follow your notes, it'll be February 11th. Now, in this video, we studied the converse of the Pythagorean theorem, and we also looked at 2 other theorems. Now, remember the Pythagorean theorem says, are you listening, students? If you have a right triangle, then the sum of the legs squared equals the hypotenuse squared. Well, this is backwards. This says if you can square the two smallest sides and it equals the square of the longest side, then you have a right triangle. So it's the converse of the Pythagorean theorem, alright? If you didn't understand that, let me explain it to you this way. I'm going to break this down to 3 simple problems, okay? Now, on the test, there's a good chance I will ask you to take 3 sides. I'm going to give you 3 sides of a triangle. And you're going to look at those 3 sides and tell me whether you have an acute triangle, an obtuse triangle, or a right triangle. Okay? And you say, well, how do we do that? I'm going to show you right now. So if I give you the 3 sides of a triangle and tell you to tell me whether you have an acute, obtuse, or right triangle, here's what you do. You take the 2 smallest sides and pretend they're your legs. And you take the largest, the longest side, and pretend that's your hypotenuse. Don't put an equal sign. I should not have done that. Just put a, I guess kind of put like a blank there. Alright, we'll fill the blank in later. Now, 4 plus 9 is 13. 4 squared is 16. 2 times 2 is 4. 3 times 3 is 9. 4 plus 9 is 13. So I end up with this right here. So whenever your legs, the sum of your legs squared is less than your hypotenuse squared, anytime it's like this, you will always have an obtuse triangle. Please, students, make note of that. There were so many of you, I remember when we took the chapter 9 test, there were so many of you who got this part right, and then you interpreted your information incorrectly. You put a right triangle or an acute triangle, okay? If the sum of the 2 squared legs is less than the sum of the hypotenuse, or the square of the hypotenuse, then you have an obtuse triangle. And really, I shouldn't put a blank here because it looks like it's less than or equal to. So I'm not sure. I guess just leave a space there from now on. Just leave a space and fill the space in with the correct inequality symbol. So this triangle here that has these 3 lengths is an obtuse triangle. Now, let's try this next one here. 4, 5, and 6. So my 2 smallest sides are 4 and 5. Then leave a little space here. And then my longest side is 6. So we have 4 times 4 is 16. 5 times 5 is 25. 25 plus 16 would be 41. 6 times 6 is 36. So now this side is greater than this side over here. So when the sum of your 2 squared legs is greater than your hypotenuse squared, then you have automatically, you know it is an acute triangle. Always. Okay? Memorize that, know it. So this triangle here would be an acute triangle. Now, let's take a look at our last problem here. My 2 shortest legs are 9 and 12. So 9 squared plus 12 squared. And then leave a space and put 15 squared. Alright? Well, 9 times 9 is 81. 12 times 12 is 144. So if I take 81 plus 144, I'm going to get 225. Now, if I take 15 squared, I'm going to get 225. unless these two numbers are equal. So anytime the sum of the two squared legs equals the hypotenuse squared, then you have a what? We just talked about it. Then you have a Pythagorean triple, which means you have a right triangle. So if both sides come out to be equal, then you have a right triangle. So a triangle with these three lengths will always be a right triangle. A triangle with these three lengths here will always be an obtuse triangle. A triangle with these three lengths here will always be an acute triangle. Know this, memorize it, and we're moving on. Okay, lesson 9.4. Lesson 9.4. If you want to look in your notes, that would be February 13th. In this lesson, we looked at two special triangles. Let me review down below, and boy, you better take some good notes, okay? Here we go. Memorize this, know it. If I have a 45-45, 90 triangle, and let's pretend this leg was a 1, then this leg would be a 1 also, and the hypotenuse would be a square root of 2. Got it? Know that. What does that mean? Well, it means this. Are you ready? Write this down. It means the legs are going to be congruent. It means your leg will equal the hypotenuse divided by the square root of 2. And it means your hypotenuse will equal your leg times the square root of 2. Now, guys, you just got to know that. I mean, you're going to have to learn it. It's just like learning your multiplication tables or Pythagorean Theorem or the sine, cosine, and tangent ratios. So, Katoa, okay? You need to know this. So, anytime you have a 45-45-90 triangle, the legs will always be congruent. The leg, either one of the two legs, will always be congruent to the hypotenuse divided by the square root of 2. And the hypotenuse will always equal the leg times the square root of 2. Now, let's say I drew another special triangle here. We're going to call the top angle 30. Please take some good notes. That's the bottom angle 60. And this 90 degrees. Okay? We're going to call the hypotenuse 2, the shorter leg 1, and this the square root of 3. These two triangles are pretty much the model unit triangles teachers use when they're teaching 30, 60, 90 triangles and 45, 45, 90, okay? So here we have a 30, 60, 90 triangle. Got it? Now here's what you need to know. First of all, you need to know that the leg, well, wait, okay. First of all, we have a smaller leg and a longer leg, okay? Now the smaller leg is always going to be across from 30 degrees. So here's 30, go across, smaller leg. The longer leg is always across from the 60 degrees, so understand that. And of course the hypotenuse is across from 90 degrees. Now, having said that, here's what you need to know. The smaller leg will always equal the hypotenuse divided by 2. Or you could also say the smaller leg equals the longer leg divided by the square root of 3. Okay? Why'd I put SM? I have no idea why I did that. Let me slide this over here. My pen is messing up like it loves to do, so hold on 1 second here. Alright. Now, I should have put SL. For smaller leg. So my smaller leg equals the hypotenuse divided by 2, or you can also say it equals the longer leg divided by the square root of 3. Now I give you both of those because you never know when you're going to need one or the other. Now the longer leg equals the shorter leg times the square root of 3. The hypotenuse equals 2 times the shorter leg. So, with this in mind, let me go ahead and copy this so I can take it from page to page. Alright, so let's go ahead and apply this to some problems, alright? Copy this problem in your notes, please. If I asked you to find the length of this side without using Pythagorean's theorem, we could do that, okay? Now, first of all, we have a 45, 45, 90 triangle, so we know we can use these shortcuts here. I'm looking for the hypotenuse. What do I know about the hypotenuse? You take your leg and you multiply it by the square root of 2. Well, your legs are 3, so x would equal, x is your hypotenuse, straight across from the 90 degrees, okay? So x would equal your leg, which is 3, times the square root of 2. Booyah. Done. Finished. That's a lot faster than using Pythagorean's theorem. If I asked for that in decimal form, it would be 4.24. So either one of those answers would be acceptable. Alright? Now, let's take a look at another problem. All that we know is we have 90 degrees. But hold it. Notice how I called this side here x, and this side over here x. That means since they're both called x, they both have the same length. We've learned that when two sides of a triangle are congruent, their opposite angles are congruent. So this angle here is congruent to this angle here. So if this angle here is 90 and these two angles are congruent, then they have to be 45 and 45 to give me a total of 180 degrees. Now, having done that, having shown you that we have a 45, 45, 90 triangle, then we can use our formulas for 45, 45, 90 triangle. So, I'm trying to find the length of a leg, okay? How do I find the leg? I take the hypotenuse and I divide it by the square root of 2. So here's my hypotenuse here. So in order to find a leg, according to this formula right here, I take my hypotenuse, which is 2 square root of 2, my hypotenuse, and divide it by square root of 2. Well, these would cancel, and the length of your leg would equal 2. So x here would equal 2, and x here would equal 2 because the legs are congruent when you have a 45, 45, 90 triangle. Alright, not too bad. Now let's move on to some 30, 60, 90 triangle examples. Let me go back here and copy my formulas here. And here we go. Right away I can see, students, that I have a 30, 60, 90 triangle, so I can use these formulas here. Now let's see what first of all, I'm going to label my sides. This is 30, go straight across. This is my shorter leg. This is 60, go straight across, longer leg. And this is my hypotenuse. Now they've given me the hypotenuse. So looking at my formulas here, to be honest with you, the shorter leg is always half the hypotenuse. Or you can say the hypotenuse is twice as big as the shorter leg. So if you know the hypotenuse, it's really easy to find the shorter leg. Right here it is in front of you. Hypotenuse divided by 2. The shorter leg is the hypotenuse divided by 2. Well, the hypotenuse is 8. So 8 over 2 is 4. So there we go. The shorter leg is 4. It's pretty simple. Now to find the longer leg, I only see one formula. It's right here. The longer leg is, you take the shorter leg and multiply it by the square root of 3. So x is your longer leg. And how do you find your longer leg? Once again, you take the shorter leg, which is 4, and multiply it by the square root of 3. So shorter leg, which is 4, times the square root of 3. And there's your answer. Now if you want a decimal for that, that's fine. The answer to that would be 6.928. Alright? But that is how you would solve this, okay? So make sure you're getting this. Alright, let's take a look at another 30, 60, 90 triangle. Now, first of all, let's label our sides. Here's your 30, go straight across. This is your shorter leg. This is 60, go straight across. This is your longer leg. So this would be your hypotenuse right here. So students, having labeled these sides right here, now let's see what we're looking for. We are looking for the longer leg and the hypotenuse. Well, the hypotenuse is always 2 times the shorter leg. 2 times the shorter leg. The hypotenuse is always twice as big as the shorter leg. So if the shorter leg's 5, then that's easy. The hypotenuse would be 10, so S would be 10. Now, the longer leg is always the shorter leg times the square root of 3. The shorter leg, 5 times the square root of 3. So the longer leg would be shorter leg, 5 times square root of 3. And we're done. If you know these, it makes it really easy, guys. Alright, one more, then we'll move on to something else. Now, let's label our sides again. 30 goes straight across. This is my shorter leg. F equals, here's 60 goes straight across. This is my longer leg, which is 10, okay? 10 equals my longer leg. And then, of course, over here is my hypotenuse, alright? Now, listen to me. Which side do I know? I know the longer leg. So I'm trying to find the hypotenuse and the shorter leg. Now, if you try to find the hypotenuse first, come down here and look at your formula. It's not going to work. The only way you can find the hypotenuse is if you already know the what? Shorter leg. Because you take the shorter leg and you multiply it by 2. Do we know the shorter leg? No. So we cannot find the hypotenuse first. So let's find the shorter leg first. Okay? How do you find the shorter leg? Well, you take the hypotenuse and divide it by 2. Well, that's not going to work because we don't know the hypotenuse. What's another way to find the shorter leg? Take the longer leg and divide it by the square root of 3. So take the longer leg, which is 10, divided by the square root of 3. So longer leg, 10, divided by what? Square root of 3. But hold it. Remember, I've taught you guys, you never want a radical in the denominator, okay? So the shorter leg is 10 divided by square root of 3. However, we have to rationalize our denominator. We have to multiply the top and the bottom by the square root of 3. We've done this before, guys. 10 times square root of 3 is 10 square root of 3. And square root of 3 times square root of 3 is 3. So there's the real length of my shorter leg. Now I can find the hypotenuse. Remember, you always take your shorter leg and you multiply it by 2. Now it's kind of weird to do that with this number, but I'll show you how to do it, okay? Take your shorter leg. We're trying to find the hypotenuse. Hypotenuse is always 2 times the shorter leg. So I'm going to take 2 over 1, which is the same thing as 2, times my shorter leg, which is 10 square root of 3 over 3. So the denominator, of course, would be 3. 1 times 3 is 3. 2 is an outside number, not an inside number. 10 is an outside number. 3 is an inside number. You multiply outside number times outside number, and you get 20 square root of 3 all over 3. Please do not reduce your fraction like this. 3 is an inside number up here. This 3 is an outside number. Now, if this 20 right here was a 21, then you could reduce the 3 and the 21. That would be fine because they're both outside numbers, okay? Or if this 3 down here was like this, then you could reduce because this is an inside number and this is an inside number, okay? But it's not the case, so we're finished. This would be the answer to the hypotenuse right here, okay? There it is. So students, I hope this has made sense. We're just trying to work on solving problems using your 30, 60, 90 and your 45, 45, 90 formulas. Alright? Alright, let's move on. Lesson 9.5 review, February 19th is where you'll find that in your notes. In this lesson, we studied sine, cosine, and tangent. Okay? Sine, cosine, and tangent. So, here we go. Let's look at some problems dealing with sine, cosine, and tangent. Copy this triangle down if you would, please. Copy this triangle down. I'll give you a second to do that. And you know what else? Why not copy this down too? Remember SOHCAHTOA. SOHCAHTOA. S equals O over H, so ka. C equals A over H, so ka toa. T equals opposite over adjacent toa. Okay, so ka toa. There it is. Okay, now these are trig ratios we're going to use. So let's look at some problems dealing with sine, cosine, and tangent. Okay, let's say I asked you to find the sine of r. Okay, the sine. Write this down, please. The sine of r. Okay, we circle r. That's the angle we're dealing with. Go straight across. This is your opposite side. Here's your 90 degrees. Go straight across. This is your hypotenuse. And the leftover side is your adjacent. Now, how do you find the sine of r? Well, the sine of r is opposite over hypotenuse. Opposite is 12. Hypotenuse is 13. So there, you just found the sine of angle r. It's 12/13. Not too bad. Let's find the tangent of angle r. The tangent of angle r. Okay, well, tangent, we're still dealing with angle r. Angle r is circled, so everything's fine up here. Tangent is opposite over adjacent, so my opposite side is 12, and my adjacent side is 5. So the tangent of r is 12/5. Alright, let's switch over to angle S for a second, okay? Angle S. What if I asked you to find the cosine of angle S? Well, let's circle S. Alright, let's circle S. Go straight across. 5 is my opposite side. Go to your 90 degrees. Go straight across. 13 is my hypotenuse. And then, of course, 12 is my leftover side. We'll call that my adjacent side. Okay, so here we go. The cosine of S would be, cosine is adjacent over hypotenuse. So adjacent would be 12 over hypotenuse. 12/13. So the cosine of S is 12/13. Okay, so really, students, not too bad. So make sure you know how to use trig ratios with right triangles. Okay, now sometimes I won't give you a right triangle. Sometimes I'll just give you numbers like this. And of course, that's where your calculator comes into play. Okay, you've got to use your calculator. Now remember, sometimes your calculator can be in degrees. Sometimes it might be in radians, even though you don't want it to be and you didn't do it on purpose. Your calculator can still be in radians, so always check and make sure that your calculator is in degrees, because we're solving problems in degrees. Okay, now having said that, let's find the sine of 35. So with your calculator, you would type in sine and then 35 degrees. Alright, sine 35, and that's going to give you this answer here. 0.5736. Alright, let's go ahead and type in now the cosine of 10 degrees. So you type in cosine and then 10, hit enter, and you're going to get 0.9848. Now some of you might have a different calculator where you hit 10 degrees first and then push the cosine button. You've got to figure out your calculator, students, and you do that by fooling around with it until you're getting out the correct answer. Okay? Tangent of 74 is 3.4874. Okay, so understand this type of math and be able to do some different problems dealing with sine, cosine, and tangent. Okay, and I've ran my stopwatch here while I've been teaching. It's just about 45 minutes. So we're going to stop there. We'll pick up tomorrow with lesson 9.6, which is solving right triangles, and then continue on from there. Okay, guys, have a great rest of the day. If you have any, hopefully this video has been a help to you. If you have any questions,